The derivative can be expressed in dy by dx or dx by dy. They are called as homogeneous functions of degree 0. If the equation can be written in the form of y by x in every variable, then it is of the form dy by dx. Now this is of the standard integral of the form a square minus x square. So what is a square minus x square? It is 1 by 2a log x minus a by x plus a. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about the homogeneous differential equation. So in our previous session, we have learnt how to find the general solution or particular solution of a differential equation by variable separable method. So here we are going to study and find the solutions for homogeneous differential equation. So what is homogeneous differential equation? So if any function, either it can be expressed in the form of f of xy or dx by dy is equal to g of xy. That is, whenever any differential equation can be expressed in the form of f of x comma y or g of x comma y, where the derivative can be expressed in dy by dx or dx by dy, they are called as homogeneous functions of degree 0. Sometimes, if any function can be expressed in the form of f of y by x or g of x by y form, that is either dy by dx should be expressed in the form of f of y by x or dx by dy should be expressed in the form of g of x by y. Then if you can express it, then it is called as homogeneous functions of degree 0. So that is, there it is called as homogeneous differential equation. Now finding the solutions for homogeneous differential equation. How to find the solution for homogeneous differential equation? First, so if the homogeneous differential equation is given of the form dy by dx is equal to f of x comma y or g of y by x. If the equation can be written in the form of y by x in every variable, then it is of the form dy by dx. There we make a substitution as y is equal to vx. We will differentiate this y is equal to vx, so that what we will get here, v is also variable of x. So here v is also a one more function. So that is why when you differentiate it, what happens? Dy by dx, first function into derivative of second, which becomes v, plus second function into derivative of v with respect to dx. So thus, in the place of dy by dx, we will replace this. So after substituting in 1, we will rearrange the variables, that is all x terms in one side, all y terms in one side, or all v terms in one side, all x terms in one side, and we will apply the method of variable separable to find the solution of homogeneous differential equation. So also note that suppose if the homogeneous differential equation is of the form dx by dy such that it is written in the form of h into x by y, then we make a substitution as x is equal to v into y. So for the first case, we will make a substitution y is equal to vx. In the second case, we will make a substitution x is equal to vy. Then again, we will continue the same process to find the solution of homogeneous differential equation. So let us see the problems and let us show that the given differential equation is homogeneous and solve it. First one, show that the differential equation x minus y into dy by dx is equal to x plus 2y is homogeneous and solve it. So we have here x minus y dy by dx is equal to x plus 2y. Now take dy by dx here. So dy by dx becomes here x plus 2y and here it is x minus y. Take x as a common factor in both numerator and denominator, then it becomes 1 plus 2 into y by x, and here it becomes x into 1 minus y by x. So x cancel. Clearly the function is expressed in the form of y by x. So this is of the form g y by x, where all variables are expressed in terms of y by x. Hence, what we can call, so therefore, it is homogeneous differential equation. So once you have shown that it is a homogeneous differential equation, we make a substitution for dy by dx, that is, we'll take y is equal to v into x. Then what happens when you differentiate it? Dy by dx is equal to, so v plus x into dv by dx. So we have dy by dx is equal to 1 plus 2 into y by x, 1 minus y by x. So here dy by dx is equal to 1 minus 2 y by x and 1 minus y by x. So what we have taken y is equal to vx, and dy by dx can be replaced with v plus x into dv by dx. So what happens? This is v plus x into dv by dx, and here 1 minus 2 into vx by x divided by 1 minus vx by x. X cancels, will get 1 minus 2v divided by 1 minus v. Now here we will shift v to the right hand side. So then it is x into dv by dx is equal to 1 minus 2v divided by 1 minus v, because we have shifted v to the right hand side. On solving this, we will get 1 minus 2v. So 1 minus v becomes minus v plus v square divided by 1 minus v. Or I can write this as v square. So here I have already minus 2v. Minus 2v minus v becomes minus 3v. And here we have plus 1 divided by 1 minus v. So we got v square minus 3v plus 1 divided by 1 minus v. So let us make the substitution for these two functions here in 1 plus 2 into y by x, 1 minus y by x. So what happens for dy by dx? Dy by dx becomes v plus x into dv by dx is equal to, so what is 1 plus 2 y by x? It becomes 1 plus 2 into y is vx by x, and here 1 minus vx by x. X cancels here, so we will get it as 1 plus 2v divided by 1 minus v. Next we will keep x into dv by dx here. We will shift v there. It becomes 1 plus 2v, 1 minus v minus v. On solving this, we get 1 plus 2v minus v plus v square divided by 1 minus v, which becomes 1 plus v square divided by 1 minus v. So now we got this equation. So let us convert all v towards the left hand side and all x towards the right hand side. So then this becomes, so 1 minus v can be taken as v minus 1, and here I can write it as v square plus v plus 1 into dv. And let me keep minus here. So I have taken v minus 1, so I'll keep minus here. So then that is dx by x plus c. Now we have separated all variables. Let us apply the integration here. Now here I have v minus 1. So if I take v square plus v plus 1 as a 1t, then the derivative is 2v plus 1 form. So for that purpose, what I will do here is, I will multiply 2 here and I will take divide by 2 outside. So then what happens here? Here I will get 2v minus 1, and here 1 by 2. I will convert this in the form of 2v. So here I have minus 2 plus 3. Now here what I will do, I will take half integral. I need 2v minus 2. So for that purpose I will take 2v, and here I will take plus 1 minus 3. That minus 2 I have taken in the form of plus 1 minus 3 divided by v square plus v plus 1 into dv. And on the other side, integral of 1 by x is nothing but log x plus integration constant. Here I will separate the variables, that is half integral of 2v plus 1 divided by v square plus v plus 1. Next I will take minus 3 by 2, that is half can be multiplied here also, integral of 1 divided by v square plus v plus 1 into dv, and on the right hand side we have log of modulus x plus c. Since this is a quadratic equation, we can express it into the form of a completing square. And here, let us apply the integral. So here we have dv also. So take v square plus v plus 1. When you derive it, it is 2v plus 1. We know that integral of f dash of x by f of x, whenever the function is in the denominator and its derivative is in the numerator, then this can be written as log of f of x plus c. Correct? So remember this. So whenever the function and its derivative is in the form of f dash of x by f of x, I can write it as log of f of x. So therefore here we can see f of x is v square plus v plus 1 and f dash of x is 2v plus 1. Hence by keeping half outside, if you apply the integral for this, it will become log v square plus v plus 1. So therefore here I can write half log of v square plus v plus 1, and here we have minus 3 by 2. So minus 3 by 2 integral of 1 divided by, using completing square method, I can write v square plus v plus 1 as v plus 1 by 2 whole square plus 3 by 4, or 3 by 4 can also be written as root 3 by 2 whole square, and here we have dv. And on the right hand side we have log x plus c. So now the second integral is in the form of x square plus a square. So 1 by x square plus a square is nothing but tan inverse x by a. So now using that relation, here we can write half log v square plus v plus 1 minus 3 by 2 into 1 by a. A is here root 3 by 2. Okay, and here we have tan inverse x. X is v plus half here by a. By a is again root 3 by 2. And on the right hand side we get log of mod x plus c. Now here you can see, you can cancel 2, 2. And again here root 3 with root 3 get cancelled. So I can write it as half log v square plus v plus 1 minus root 3. So here I can cancel 2 to both the denominator and write it as tan inverse 2v plus 1 divided by root 3 is equal to minus log mod x plus c. Initially we have taken y is equal to v into x. So what is v? V is equal to y by x. So in the place of v here, just replace it with y by x. So then what happens here? Half log. So this becomes y square by x square plus y by x plus 1 minus root 3 tan inverse. Here it becomes 2 y by x plus 1 divided by root 3, and here we have minus log mod x plus c. So therefore it is half, multiply x square here. So it is y square plus xy plus x square minus root 3 tan inverse. So here you can write it as 2y plus x divided by x root 3 is equal to minus log mod x plus c. So this is the solution for the given differential homogeneous equation. Next question. Show that the differential equation x into cos y by x dy by dx plus y cos y by x plus x is homogeneous and solve it. Clearly by observing the function, see here dy by dx can be written as, so you have here y cos y by x plus x divided by x cos y by x. So if you take x as a common factor in both numerator and denominator, x common factor when you take in the numerator, denominator also comes out, so it will get cancelled. You can write it as y by x cos y by x plus 1, and here you have cos y by x. So now all the variables are expressed in the form of y by x. That is g of y by x. So therefore clearly it is homogeneous differential equation. Now since it is homogeneous differential equation and it is of the type dy by dx, I can put y is equal to vx. So this implies dy by dx can be written as v plus x into dv by dx. Now let us substitute these two terms in the equation. So dy by dx can be written as v plus x into dv by dx. And there you can write it as y is taken as vx, correct? So vx by x means it is v now. Again vx by x it becomes cos v plus 1 divided by, here again cos vx by x becomes cos v. Now observe the right hand side, divide both terms by cos v. So then it becomes v plus 1 divided by cos v, or 1 by cos v can be written as v plus x into dv by dx is equal to v plus secant v. On both sides plus v we can cancel. We can rearrange v and x. So therefore here you can write it as dv by secant v is equal to, here you can take dx by x. Apply the integral, then add integration constant. So here you can write 1 over secant can be written as cos v dv, and here you have log mod x plus c. So integral of cos v is sin v, and here you have log x plus c. What is v? Y is equal to vx means v is equal to y by x. So therefore here I can write sin y by x is equal to log mod x plus c. So this is the solution for the given differential equation. Next question. Show that the differential equation x square dy by dx is equal to x square minus 2y square plus xy is homogeneous and solve it. So express it in the form of y by x, then it is proved that it is homogeneous. So let's write dy by dx is equal to x square minus 2y square plus xy divided by x square. So when you divide the terms by x square, here it becomes dy by dx is equal to 1 minus 2 y by x whole square plus y by x. Say clearly the function you have expressed in the form of y by x. So therefore it is homogeneous differential equation. Since we have the type of dy by dx, we can make a substitution y is equal to vx, and such that dy by dx can be written as v plus x into dv by dx. Now let us make a substitution. In the place of dy by dx, we write v plus x into dv by dx is equal to, and here vx can be replaced for y, then it becomes 1 minus 2 into vx by x whole square, and here we have plus y by x, so it is plus vx by x. Xx get cancels, so I can write v plus x dv by dx is equal to 1 minus 2v square plus v. Plus v get cancels on both sides. Then we have x dv by dx is equal to 1 minus 2v square. Or I can write it as dv divided by 1 minus 2v square is equal to dx by x. Apply the integration on both sides, add integration constant. Here this can be expressed as dv divided by 1 minus or 1 square minus root 2 v whole square is equal to dx by x plus c. Now this is of the standard integral of the form a square minus x square. So what is a square minus x square? It is 1 by 2a log x minus a by x plus a. So now applying the standard integral, this will become 1 divided by 2 root 2 log of modulus 1 plus root 2v divided by 1 minus root 2v. So this is for the standard integral we have here. Next, on the other side we have log of mod x plus c. Now just replace the value of v here. V is nothing but y by x. So therefore here I can write it as 1 by 2 root 2 log 1 plus root 2 y by x divided by 1 minus root 2 y by x modulus log mod x plus c. Now here on solving we get 1 by 2 root 2 log, since both contains the denominator x, it get cancels. We have x plus root 2 y, x minus root 2 y log of mod x plus c. So this is the solution for the differential equation. Next question we have, for x plus y dy plus x minus y dx is equal to 0, find the particular solution solving the given condition y is equal to 1 when x is equal to 1. So here the condition is given for y is equal to 1, x is equal to 1. That means first we need to find out the general solution and apply the values, and then we'll get the particular solution. So we have x plus y dy plus x minus y dx is equal to 0. So if you convert this, this is x plus y dy is equal to x minus y, I can take it as y minus x dx. So then I'll get dy by dx in the form of y minus x by y plus x. So here x plus y I have written in the form of y plus x, which is one and the same. Now if you take x as a common factor, then it is y by x minus 1, y by x plus 1. So again this is of the form y by x. So therefore clearly it's a homogeneous differential equation. Now we need to solve it. We know that we can make a substitution for y is equal to vx, and dy by dx can be written as v plus x into dv by dx. And on the right hand side, if you put vx here, xx cancel, this becomes v minus 1 by v plus 1. Now shift v to the right hand side, then x into dv by dx is equal to v minus 1 by v plus 1 minus v, which becomes v minus 1. V plus 1, when you multiply, v minus v becomes minus v square, and plus 1 minus v becomes minus v. So divided by v plus 1. And on solving here, plus v minus v get cancels. So I will get here minus v square plus 1 divided by v plus 1. So next here, I will separate x variables and variable v. So now I will separate the x variable and variable v towards the either side. Then it will become integral of v plus 1 divided by v square plus 1 dv. And you have negative on right side. So therefore it is minus dx by x plus c. So now here v plus 1 by v square plus 1. If I convert this in the form of f dash of by f of x, then I can write it as log. So for that purpose, so what I will do here, I will take it as half and multiply 2 here, so that it become 2v plus 2 there. Then I'll write this as, or I'll split it as 2v plus 1 divided by v square plus 1 dv. And on the right hand side, we can write it as log mod x plus c. Now here I can write it as half integral. So I can write it as 2v plus 1 divided by v square plus 1 dv plus again half integral 1 divided by 1 plus v square dv log mod x plus c. I have minus here, so I'll put minus. And now this is in the form of f of x and f dash of x. where f dash of x is in the numerator and f of x is in the denominator. So therefore, I can write it as half log modulus v square plus 1. And here this can be written as tan inverse v. So because integral of 1 over 1 plus v square is nothing but tan inverse v. And here I can write it as minus log mod x plus c now. So now we have to convert it into y and x because we need to substitute for y and x. And also we can see here, since y is equal to vx, we have taken y is equal to vx. This implies v is equal to y by x. And also y is 1, x is 1. This implies v is also 1. Suppose if you put v is equal to 1 here, because both x and y are 1, therefore v is 1 here. It becomes half log 1 plus 1 plus tan inverse 1 minus log 1 plus c. Log 1 is 0. And here tan inverse 1 is nothing but pi by 4, because for pi by 4 tan value is 1, and this becomes half log 2 plus pi by 4 is equal to c. So this is the particular solution for the given homogeneous differential equation. So this is how we are going to find the solution of homogeneous differential equation. So first we will verify whether it is a homogeneous by converting it in the form of a y by x form. That is, all the expressed variable must be in the form of y by x. Once it is homogeneous differential equation, then we'll make a substitution of y is equal to vx. And once this is expressed, we can write dy by dx is equal to v plus x into dv by dx. So if this is also replaced, then we will separate the variables of v in one side, variables of an x in one side, apply the variable separable method to find the solution. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.